Welcome to our new Unit 10. Our Unit 10 is on systems and matrices. There's two places that you can get your notes and homework. One is a mini packet for just this current week. I labeled it eWeek 3. You could either print this or download it to Notability. Has both the notes and the homework. Another option is to click on each day. You'll see your notes, your homework, and a place to submit your homework, and then there will also be a link to these videos. Our first lesson today is going to be on a 2x2 system solving using substitution and elimination. This lesson should feel very familiar to you from Algebra 1. Just a little warm up here. You can pause this video and try this on your own. Just using your geometry knowledge, see if you can conclude the number of intersection points of. Pause the video and see how you do. Welcome back. When we do an intersection of two lines, we will have how many solutions? Just one solution. Parallel lines, because they're parallel, they do not intersect, so we will have no solution. And the word coinciding basically means the same line. So if we have two lines that are the same, right on top of each other, I can show that easier with different colors. They have every single point in common, so there'll be infinitely many solutions. And sometimes I use shorthand, IMS, for infinitely many solutions. The first thing we're going to do is determine if a solution is, or if an ordered pair is actually a solution. We're going to plug it in, but you want to make sure when you plug it in, you plug it into both equations, and it works out true for both equations. We're going to replace the x, and we're going to replace the y. I'm going to do that in just the first equation here. So 4 replacing the x, then plus 3 replace the y, and it's almost like a big question mark. Does it equal negative 13? If we have negative 16 plus 3, does that equal negative 13? And yes, they are equal. And you are not done. With a system of equations, you need to make sure that it's actually true for both equations. So we do need to take that same order pair and plug into the other equation to find out if it is a true or false. Plugging in, if you see that negative in front, really we have a negative or a negative 1, you can write a negative 1, be multiplied by our negative 4, plus and replace the y with the 1, and I'm going to put a box, and it's kind of our question mark asking if it's equal to 5. So this equals 4 plus 1, and so yes, 5 equals 5. So the question is this a solution to the system? So yes, solution to the system. And no matter how many equations there are in a system, we'll start seeing equations that have 2, but we will also see 3 or more equations for systems. It has to be a yes or true for all of the equations in the system. Our next problem is going to be a review of substitution. Now, I personally only like to use substitution when the problem lends itself nicely for it. For this type of problem, probably would have used elimination. However, I want to review substitution with you. For substitution, it's easiest to take one of your equations and solve for a letter. So in this problem, let's take the second equation and let's add our 2y over and get our x by itself. So we get x equals 2y plus 1. Now on a test or on an exam, I personally would give you a problem that's already set up nicely for substitution. I would never ask you to do a problem like this that looks more set up for elimination. However, I wanted to show this to you because the book does have some set up this way. So if we have our equation, and I'm going to rewrite them, this is typically what a substitution problem would look like. What they're asking you to do is take that x equals and replace it for the x in the other equation. And you want to make sure that when you replace that you use parentheses. So rewriting my first equation, but replacing my x, I'm going to replace that x with 2y plus 1. And then continue writing minus 3y equals 14. And from here, hopefully it's easy enough for you to solve. You could always solve on your own, pause the video and come back. So 8y plus 4 minus 3y equals 14. Combine like terms, 5y plus 4 equals 14. Subtract your 4 to get 10, and your y is 2. Now remember, this is a system of equations. It's two lines that are going to intersect at a point. So you need to find both the x and the y value. Come back here to your x. So now if we have our x equals, we can replace that y, replace this y here with 2. And we get our x is 5. Now, I know we don't have paper exams on this, but if we did, I would require you to write it as an ordered pair. And I know that there's a lot of people out there that just tell me the x equals and the y equals. But I want you to realize what these are. They're intersections of two lines. And the intersection of two lines is a point. And so I do need you guys to write it as an ordered pair. Our next problem is going to help us review elimination. I typically use elimination anytime things are stacked. Just as a reminder, the book sometimes throws some problems at you where maybe it's not equal, or maybe they have an x stacked over a y, and you have to rearrange your problem to get things set up where your x's are stacked, your y's are stacked, and it's equal to your number. I jumped into a harder problem. Sometimes they'll have some problems where you only have to multiply one equation or maybe none. The first thing you want to do is think about what letter to eliminate. When you eliminate, you want things to be equal to 0, which means to get something to be equal to 0, we need to have the same number and opposite signs. You could eliminate both x or y, it does not matter. I'm personally going to choose to eliminate the y because they already have opposite signs. I'm going to think of my multiple of what they both go into, and that would be 6. So I'm going to multiply this first one by 2 and the second one by 3. And then rewriting my two equations. If I distribute my 2, I get 4x plus 6y equals negative 2. And then 9x minus 6y, and 18 times 3 is 54. And now what we're going to do is we're going to add up those two equations. So I'm going to give myself a little bit more space here, and I'm going to add up those equations. And then when you add them up, it should be set up where one of your letters goes away. Here the y's cancel out if I add them up. If I add up the x's, I get 13x equals 52. And when you divide by 13 to solve for x, you get x to be 4. And now you have a choice. You can plug back in to any of the equations. You can plug into my blue adjusted equations. I typically always go back to my original ones, just in case I made a mistake somewhere along the way. And it doesn't matter which one you choose. I think I'm going to choose maybe the first one, so I'll highlight that. And I'm just going to rewrite it. So 2x plus 3y equals negative 1. And now I'm going to replace the x that I found and solve for my y. So replacing my x with 4, so 2 times 4 plus 3y equals negative 1. Continue solving. We have 8 plus 3y equals negative 1. Subtract 8 to get negative 9, and divide by 3 to get negative 3. Your ordered pair solution is x comma y, 4, negative 3. 2 more problems to do, and these I'm giving you a variety or options on how you choose to solve. The book used to have us find a letter arbitrary if it was infinitely many solutions. I have cut that from the directions, so when you look at today's bookwork, it'll be highlighted out. I cut it from the answer key so they don't get confused, but typically there is a little bit more to this lesson. If we were in class, we would expand upon it. It wasn't that big of a deal, so here we're just going to keep things a little simpler. I would choose to do elimination, and maybe this time I'm going to choose to eliminate my x's. They already have opposite signs, and it looks like I would just need to multiply the first equation by 2. And multiplying my first equation by 2, I get 14x plus 6y equals -10. And then I'm going to rewrite my next equation, -14x minus 6y equals -10. And then I'm going to add them up. When I add them up, you're going to see what happens here is that the x's cancel and the y's cancel, so this side equals 0. And then -10 plus -10, careful, is -20. Those do not cancel. If your letters cancel out, so there's no variables, and if this is false, we agree that 0 does not equal 20, then what would your conclusion be? You're right, our conclusion is no solution. And if the goal of the problem is to find the solution, we would say there is no solution. If I were to extend your thoughts and ask you what the lines would look like, they would be parallel lines because they do not touch, implying that there's no intersection and no solution. And let's try our last problem for today. Choose which letter you wanted to eliminate. I'm going to go ahead and eliminate my x's by multiplying the second equation by 3. I'm going to rewrite my first equation, and then I'm going to multiply my second equation. So 9x minus 3y equals 24. When you add these up, my x's cancel out and my y's cancel out. Leave that placeholder of 0. 24 plus a -24 is 0. If all your variables cancel and you get something that is true, when they say how many solutions are there, there's going to be infinitely many solutions. IMS is my shorthand. And if these lines were described, we would describe them as the same line. Now, like I said, typically in the book they would have us do something additional to this problem, but we're going to be done for today. Your lesson or your homework is eDay10. It says to do it with substitution. Yes, I understand that some problems might be better for elimination, but if you could get your practice for substitution, I would appreciate doing substitution. The next few are elimination. Those are all set up nicely for elimination. Maybe 25, you have to move things to the other side is typically how I set it up. And then there's a few more down here. They want you to decide if it's inconsistent or infinitely many solutions. You can notice that I deleted some directions that made things a little bit more complicated. And I also whited out the more complicated portion of your of the answers. I do need to see work. So don't just say IMS or no solution. I need to see work for all of these problems. And then at the bottom, this one I would definitely star. It used to be on our exam. I haven't thought about our Schoology remote exam yet, but please be prepared for a problem like that. And this last one is perimeter. So that is your homework. You can do it in Notability, you can do it on paper, and you're going to submit your homework to eDay10 just like you have been doing. I hope you have a great